With that said, I am Greg Fritz. I'm the VP of Data Solutions at Costrategix. I will be doing the first half of this, and then I will turn it over to my colleague Tarun, who is a Data Solutions Architect and is a SnowPro certified individual. It means that SnowPro certified is the Snowflake certification process, so he's actually passed the exam. So he's like way smarter than I am. So I'll give him all the difficult questions. The agenda, first, very briefly, and again, I'm going to be flying through the stuff as quickly as possible to leave the time for the demo, which, technical people tend to like better than a whole bunch of slides. But I think it's important to give you a bit of reference point, a context for what Snowflake is. So I'm going to talk a little bit about what and why Snowflake. Then I'm going to give a very high level and quick overview of the technical architecture and what makes Snowflake special. And then, like I said, I'm going to turn it over to Tarun to do a demo. And then hopefully we'll have time at the end for discussions and questions. Really briefly, Costrategix, we're located and headquartered here in Cincinnati, Ohio since 2006. We help organizations go digital. We are primarily a data and analytics practice, with digital transformations kind of being, an offshoot of that. Obviously, really leading with strategy and then helping you with the technology. We're a bunch of technologists that like to solve problems and help businesses achieve their outcomes. I think it's key to note. 2 years running, recipients of Business Career Innovation Award. Last year and this year, 2019 Best Places to Work finalist, and we're waiting to hear on 2020. And on the right is just some of the subset of the logos that we currently work with. And then finally, just some of the products and partnerships that we have. The top there is we are Snowflake partners, Microsoft Azure partners, BigCommerce and Calibra partners. And then the bottom half is just a small subset of some of the solutions and technologies that we work with to provide solutions to our customers. So Snowflake, why Snowflake? You can't, this is a great quote from Snowflake. You can't use yesterday's technology to solve today's data problems, and definitely not tomorrow's data problems. And that's what Snowflake is about. It's a technology solution built for the cloud, built on the cloud, not adapted for the cloud, to solve today's growing data needs and data warehousing needs, data analytics, right? So it all kind of started and grew out of the rise of the cloud, which effectively removed physical limitations of infrastructure, gave us virtually unlimited compute and storage, and with that, gave us this great digital transformation with applications and all kinds of data. IoT, social media, log data, whatever. And businesses saw that and said, this is fantastic. And they saw some, companies making, incredible use of that data. And people started to learn that data is gold and you can make money and drive business and better business with data. And not only that, so the analytics side of it, when they saw that, the need to utilize business to do your daily job and provide services got pushed further and further out within the organization, to the point where virtually everyone has some involvement in BI, data analytics functionality. And what does that mean to you all, or all of us as the IT folks? It says it's basically, there's all this data, we have to do something with it, we have to make better and quicker business decisions with it. And not only that, because we're trying to maximize the money we get out of this business, we need to reduce costs, because if we're spending money on infrastructure and other things, we're not spending the money on getting the value out of the data. And at the end of the day, what all that means is we have to take all this data, provide it quickly and with quality, so that our companies can provide a great customer experience, which is how we drive the business value. And kind of on this evolution, just to follow along with that that line of thinking, data data warehouses kind of evolved over the years, right? You had on-premise and it was very isolated. You had your SQL database. It was probably very siloed because it was only one organization or business unit that really kind of was getting into the data. And that worked. And then another business or business unit saw it. And so you had another silo and maybe another silo. And then you started to get into resource issues. And then came kind of the next phase, which was the cloud. And it solved all those infrastructure and the storage and all those. But at the end of the day, it was an infrastructure play, right? It solved the infrastructure and the time to implement it. But you still effectively had the same silos and you still had the same SQL databases and very narrowly focused use of the data. And then came along, the data lake and Hadoop and all of those other services, and actually introduced some new technologies or evolved some technologies to handle the massive amounts of data. Required us to learn NoSQL, but even there, it was more of an evolution of products that still had a lot of the maintenance costs that went along with the previous generations of solutions. And Snowflake said, right, look at what the cloud has done in terms of easing your management of your infrastructure. Why can't we do the same thing for data warehousing? So they took the advantages that you have of unlimited storage and compute and all the things that the cloud gives you, and they said, let's build a data warehouse from scratch that is built upon that and not evolved. So now we get the full benefits of the cloud and the same savings in terms of maintenance costs. So not going to spend a lot of time here. Point is, over your evolution, you may have various phases or data stores within your architecture, your data architecture, as your solution and your architecture and your business practices evolve. You may have brought in new technologies that seem to address this niche or that niche, but the problem is you end up with a very diversified and things all over the place and many versions of it, and so it makes it difficult. Each one of those, of course, may have some cost associated with it in terms of maintenance or even infrastructure or whatever, but it also makes it difficult to manage it because from a data quality or data governance, you have things in multiple places. You have to know who needs access to the data in this place or that place. So there's challenges there, and that's really what this is all saying is, even with the traditional platforms, you still have infrastructure, design, query tuning, availability, and maintenance and cost that you have to worry about. Snowflake said, right, just load the data, query the data. Let us take care of all the rest of it, right? And they do that, and that's what we're going to talk about is how they're able to do that. And what you end up with, instead of that very disjointed architecture with data in multiple places in different phases, is all of your data services. You have your sources on the left, you have your consumers on the right, and everything else is in one place in Snowflake using the same tools, using all the services that Snowflake provides, which we'll talk about a little bit more in the architecture discussion. And the great thing about it is choose your cloud platform. It supports all three major: GCP, AWS, and Azure. So that's the why of Snowflake. Then the question is, sounds great, Greg, how in the world are they going to do that? So that's going to try to really quickly go through the Snowflake architecture and give you the how. Snowflake's architecture has three, you might call it four layers if you include the cloud agnostic layer, which basically gives you the support of the three major providers. The first layer really is centralized storage. And the important thing about this is each of these next three layers are separate and independent of one another. And we'll talk about that a little bit more. But you have your centralized storage layer. To get to your storage, you have your cluster compute layer. And just a note that Snowflake uses the term warehouse for that compute layer. So don't get that term confused in other contexts. So when you hear warehouse in Snowflake terms, it's the compute layer. And then surrounding those two layers, you have the cloud services layer, which manages all of the access to those other layers and provides other services. So let's go into each of those a little bit more. So you're starting out with your storage and your compute. Your storage is separated from compute, which is really important. First of all, in traditional databases, your compute and your database is all competing for the same CPU resources. So the separation of those two, first of all, is a significant advantage. Not only that, your storage being separate and distinct from everything else, you get the capability to grow your storage as much as you need to, independent of your compute. Your compute can be resized instantaneously. And not only that, but your compute, you can have multiple clusters of compute resources. Each of those clusters of compute resources, you can direct users or user groups to those specific clusters of resources so that you can ensure you can provide the performance that you need for that set of users. And not only that, you can track the cost by compute resource, by compute cluster. And each of those compute clusters is independently scalable vertically and horizontally. The other quick point I want to make about the storage is Snowflake has a proprietary storage mechanism where they have encrypted and compressed storage, and all of the rights or the rights to the storage is immutable. And what that means is you no longer have to worry about read-write contention. So no longer are your reads waiting for someone who has a write lock on the storage. So that, and the way they do that is they have pointers to the blocks, and they maintain the pointers to those blocks to eliminate that, and also provide other functionality that we'll talk about later that's really cool. Then on top of those two, as we talked about, you have your services layer, which provides all your centralized management. It is, again, separate from your storage and your compute, so you eliminate contention there. And it provides the services to, as I mentioned, you have the storage layer managing the pointers to the data in the blocks. And what the services layer does is, in addition to handling all your security and your optimization, your query optimization, it manages the access to that storage so that you have fully transactional consistency across your queries. The other interesting architectural feature of Snowflake that provides that helps provide the incredible performance that they provide is they have caching at 3 layers. First of all, in your metadata up in your services layer, they have caching up there. For your query trimming, they store the metadata about the queries that are returned for future use on subsequent queries. They have caching at the data layer, or what they also term the local disk layer. That is also known as the virtual warehouse layer. So within the warehouses, there is a cache there, so that subsequent queries for the same data don't actually have to go to the storage. And then they also have caching at the query results layer, or what they call the remote storage. And really what that is, your cloud storage layer. So they have caching at 3 layers to greatly improve the performance of your queries. And what this means, this architecture, is that you now have access to your data, the same data, to multiple users. Each of those users are directed through their own set of compute resources. That storage is elastic and that can be scaled. Your compute is independently elastic and it can be scaled vertically and horizontally. And each of those compute layers is independent of the other, so it won't affect the other users. So you can have Dev QA, you can have your ETL, your data science team, all accessing the same data at the same time without impacting one another. The other interesting architectural aspect of Snowflake is the support of semi-structured data. Your JSON, Avro, XML, Parquet, ORC files. It is handled and the same way that structured data is. Snowflake provides SQL, standard SQL extensions to access the data. So you can ingest semi-structured data directly into your database without having to worry about transforming it. And you get all of the same storage optimization, all the same query optimization, and all of the same caching that you would with structured data. So that's a huge savings in terms of not only the need to transform it, but your ability to query it, and that semi-structured data can be queried as part of, created into views and whatever you need, same as structured data. So I think that's really cool. This slide really talks about, I talked about those other benefits of the way they do their storage. And because they keep the pointers to the storage in order to provide access to that data, they simply create copies of the pointers and not the data. And so what that allows them to do is a couple of things. First of all, sharing data is incredibly easy. So if you have data providers, they have interesting data sets that you want to use, within a matter of moments, seconds, they share the data, they create a share for you, and you, as a Snowflake user, have access to that data instantaneously without them doing unloads and SFTPs and all of those things that you may have to do today. The same way on the way out, if you have interesting data sets, you can share them out to any customers, both public and private. They have security set up for that, and you can now monetize your data if you have interesting data sets. Not only that, but the next part of it is, and we'll talk about this later, is this storage architecture gives them the ability to do what they call zero copy cloning. And I think we'll get to that later, so I'm going to hold off on that, and time travel. So just kind of pulling all of these architectural things together, I'm very quickly going to walk through just what it looks like from start to finish. And again, it's extremely high level. So as normal, you have your data sources on your right or your left, your users on the right. Snowflake provides a couple, or you might call three main methods for ingesting data. So for your web servers, your IoT, your near real-time or stream data, they provide a service called Snowpipe, which is REST API based. And the interesting thing about that is you're using their compute resources when you're doing that. The second is the kind of what is traditionally your batch copy. Snowflake has a concept of a stage that you need to provide, which is your whatever whatever cloud storage you use, whether S3, Azure Blob, or GCS, and you stage it there, and then there's a copy into command. You can either do that through the console, or they have SnowSQL, which is really a CLI-based SQL to do that for scripting. And then a put copy for on-premise. I think the only other thing I'm going to point about this in the interest of time is the concept of ELT or ETL. Snowflake suggests ELT. They basically say, get it into Snowflake, do your transformations within Snowflake. They give you the ability to transform data as part of queries once it's into Snowflake. And not only that, but they will tell you that a lot of the transformations you do today won't be necessary because of the performance they can offer. So once you have the data in, or as you're importing your data, whether it's structured or semi-structured, it's going through the services layer, which is updating the metadata and then storing it into the database. You then have these same three layers that we've talked about with your metadata and your up in the services layer, your virtual warehouses and your storage. And within each of those warehouse or compute clusters, you have your caching layer. Each cluster or each warehouse has its own caching layer. And so what happens then is your query coming in on one goes through the optimizer to do all the pruning and query optimization, et cetera, sends it down to the compute layer, and in many cases, depending on your use case, I guess, and your business users, you'll hit the cache and you won't ever go to the storage. The response is cached up in the metadata in the services layer, and the query is returned to the end user. The other thing, so I'm just a couple of minutes here left to go through just a few data protection types of concepts, and it'll tie back to some of the things we said before. Basically, protection against infrastructure failures. So basically, because you're using cloud services, all of the protection you have within the cloud in terms of multi-zone and multi-regional are utilized, and they have 3 copies of your data across independent infrastructure. Talked about protection against corruption and user errors, and this is the time travel concept, where because they're keeping pointers to the data, they maintain a pointer to the previous data. They don't get rid of it. So you actually can go back in time up to a certain degree, and there's a limitation on that, but you can go back and say, show me this data, 3 days ago or whatever it is, right? So that's really cool. And that also provides you this concept of undo. So the time travel, you can basically, those oh shoot moments where you drop the table, you can undrop it. There's actually an undrop command. So that's incredibly cool. And then long-term data protection, that gives the ability to the 0 copy clones that we talked about, and you can also export your data to cloud storage. This really just talks about the availability. So in interest of time, I'm really the only thing I'm gonna say here is all of the infrastructure and all the services are managed by Snowflake, or the vast majority of them. There's still a little bit of security you have to do, but the vast majority is managed by Snowflake. And talking about security, it is protected by industrial strength security. They have authentication, they have RBAC, role-based access control, all of this, all the way down to the table and row level or column level, similar to what you would see in Oracle. As I mentioned, data is encrypted at rest, and they also support many of the standard, HIPAA and PCI standards that exist. And then really the last thing I'm going to say here is, whereas I said it replaces a lot of the old technologies, that doesn't mean that Snowflake doesn't play nicely with a lot of the other technologies. In fact, Snowflake this is a really, really limited view of their partner ecosystem. They have partnerships, and they support probably most of the technologies and the solutions and the products that you have in your data and analytics architecture today. And so just to sum up, the key here is you have one platform, one copy of data, many workloads, and it's all in Snowflake where you can manage it. Whew. That was a lot. So with that, I'm going to turn it over to Tarun to show you a demo of many or several of the concepts that we've just gone through.
Okay, thanks, Greg. Let me share my screen. Are you guys able to see my screen?
Yep, it's coming up.
Okay.
We now can.
Okay, thanks. Okay, so with respect to demo, I apologize, if I'm going too fast, but there is a lot of content to cover. In case you think the pace is too fast, you guys can please, stop me, and I'll try to slow down. For today's demo, we'll try to cover these topics which are there on the screen right now. We'll try to cover quickly what does a Snowflake Web UI console looks like. We'll go through the demo of loading the data within Snowflake. We'll look at both structured as well as unstructured data. We'll play around a little bit with the warehouse. How do you, size the warehouse? How do you scale it up, scale it down? The caching mechanism, which Greg just mentioned, as well as, we'll look into time travel, as well as, we'll also look at the zero copy cloning if we have enough time around that. So, if you've not already done that, you can actually create a trial account with Snowflake. You can log into trial.snowflake.com. It gives you around $400 worth of free credits, which you can use to basically for a month, and then you can play around with Snowflake, which I strongly recommend. If you're trying to figure out the Snowflake, how easy it is to use Snowflake, the trial account would definitely come very handy. Now, when you register for a trial account, it gives you an option where do you want Snowflake, to be configured, and it is available on all three platforms, on Azure, on AWS, as well as on Google Cloud. When you create that, it will send you a link. This link is unique for everyone. So the one that I'm using right now, if you look at my screen, the first part of this link will give you the account. This is the account that you have within Snowflake. It's unique to you. And the rest of the two parameters after that will show you that what cloud platform that is loaded. So for me, I have registered that on the Azure platform, and this is within the East US region right now. So I'm going to use this URL, and I'm going to log in. Now this is the Snowflake web UI. This is probably the first entry point for most of the users, when they're using Snowflake. There are other options, and there are a lot of other connectors. I'll just also list them down through which Snowflake can be accessed. Now, if you look at the screen right now, you'll see that the Snowflake web UI has multiple options on this particular screen itself. I'll start with the top left corner. You can see the first one, which is database. One important point is that Snowflake supports ANSI SQL standard. So most of the things that you'll see here, if you've already worked on SQL, it will be very, you'll be quite comfortable with it, and you'll be familiar with, most of the concept that we're discussing. But there are a lot of additional features, which Snowflake provides, and I'll keep on mentioning those, as we come about. So for database, it's basically just a database that you create in any other, other data warehouses as well. When you click on the database option, it will list down all the databases you have access to. You can also, create, clone, drop. From here, this is the web UI, so you can do it through here, or you can also use the SQL command, to run that. Now, when you click on the database, it will give you an option to basically create the objects within the database. So, you can create your tables, your views, your schemas, the file format sequences, all these concepts, which you come across in a database. There are some additional concepts of stages and pipes, and I'll come back to that. The second option is shares. Already Greg mentioned, there are options within Snowflake wherein, if you are a data provider, you can share your database with other data consumers, which can be either Snowflake customers, or they can be outside Snowflake as well. You can also be consumers for other data providers. So you can use the share option to basically use somebody else's database as well. It's very easy to use it through shares. Another new feature which Snowflake recently rolled out was data marketplace, the third option that you see here. Data marketplace acts as, as the name suggests, as a marketplace, wherein if your use case or if you are a data provider and you want to make the data available as public or privately to other outside your organization, you can do that. You can also consume other data sets. For example, if you have there are a lot of data available in the marketplaces, say for COVID-19 data, that is available. You can just go to the data marketplace, subscribe to it, and you can start using that data, without having to load it or do anything. You can just directly access that. The fourth is the most important one out of this, which is basically the warehouses. So Greg mentioned about the architecture. So if you have, if you've seen this, and I think you'll come across this particular, architecture time and again, the important thing to realize is that the storage is centralized, and it's totally decoupled from the compute. The compute is what is called as warehouse within Snowflake, and you can provision multiple warehouses, within Snowflake. So if I go back here, this is the place wherein you can create a warehouse. The warehouses are basically have different sizes. They go by t-shirt sizes. So the smallest one is XS, then it goes to small, then medium, then large, goes up to 4X large. What does this mean is that XS is basically one server behind the scene, and then it goes, it increments by a factor of 2. So you have 1 server, 2 server, 4 server, 8 servers, and it goes on. The important thing is also to know that you can very easily, while creating the warehouse, you can select a warehouse size, but then you can also, sorry, you can also resize it, whenever you think that that's a particular size is not, is not something that that is working for you, and you would like to either scale up or scale down. And the sizing does not impact any of the running queries, while the warehouse is up. The other options while creating the warehouses that you'll come across is the cluster. So in case of Snowflake, when you have an enterprise edition and above, you have a mechanism of supporting multi-clustering. This is basically to help with concurrency. So if you have a lot of users using the same warehouse, you can have multiple clusters of the servers that you can configure here. Two very important attributes of a warehouse, which will help you, with saving the cost of Snowflake, is the auto suspend and auto resume mode. Now, most of the or the maximum amount of cost that you will incur in Snowflake is for the warehouse, or basically the server instance that is running. But Snowflake gives you an option to basically, suspend the warehouse if no query is running for whatever period of time you select. So if I select this as a 5-minute period of time, after 5 minutes, if there are no queries running on it, the server will come down. If there are no servers running, if there's no warehouse running, it will not charge you any credits for that. Similarly, if it is suspended and now you have auto resume enabled, that would mean that the moment the warehouse is called with a query, the warehouse will start on its own. So this is a brilliant way of, probably not running your, warehouses when you don't need it, and you can scale up and down, as and when you need it. So it's very flexible, when it comes to creating the compute, for accessing the databases. I'll skip the worksheet. I'll come to that later. The other option is the history option. So basically, whatever you run as part of Snowflake, all the queries can be accessed using the history option. History option retains the data for the last 14 days, not only for yourself, for all the other users as well. You can actually go through all the queries that you've run in the past. It has a lot of other performance parameters that you can go through. You can also, of course, drill down into a particular query and look at the query plan behind it, and look at the exactly how is it, what was the detailed plan around that query. The other option on the right hand side, the rightmost part, is you will see that within this you will have roles. Snowflake is basically role, it follows the role-based access model. So these are the predefined set of roles. You do have options to basically create your own roles in your own role hierarchy, but right now for this instance, we'll just use sysadmin. Now, account admin, just want to mention account admin. Account admin is like as a super user who who can basically access everything within a system, and it can additionally also access the billing information. So if I switch this from sysadmin to account admin, it will give me one more option called account, and that is where I can see how many how many credits within the Snowflake have I utilized, or what is the cost consumption for Snowflake so far. It has other options like creating users and those kind of administrative access, along with along with the billing information that you can access if you have the account admin role. Another important link is within the help. You can see there is a download option. So I mentioned that you can access Snowflake using other options as well. Snowflake comes up, also has a CLI client. So basically that's called a SnowSQL. You can basically download this for Linux, Windows, or Mac OS, and then you can access Snowflake the way we are doing here, but through command line interface. It is also used to basically load the file. Or stage the file. We'll come to that point, using the CLI client. You of course also have the other options of JDBC drivers, ODBC drivers. You can pretty much connect with any other tool, like even your BI tools like Tableau or Power BI, and it has connectors for Python, Spark, etc., etc. We'll come to the worksheet, which is where you would write most of your queries. So if you look at this, if you look at this plus tab, you can create multiple worksheets. For each worksheet, the important thing to note is that when you start working on a worksheet, you have to set the context in which you want to run your queries. When I say context, a user can have multiple roles, so you have to start off with what role do you want to use while you run the query. As we mentioned, while accessing the data, you need a warehouse. You need a compute to be provided. So you select, what warehouse you have. Now, right now we have, a compute warehouse with an access. This comes along with your trial account. As I mentioned, if I want to, like, say, I want to increase the size of this particular compute, I can do it very easily. I just moved it from an access to a small size, and that's about it. It is provisioned. Now I have 2 servers to run my queries. The other thing is, you can basically choose the databases and the schema that you have. But for this particular demo, we'll create our own database. For the purpose of this demo, we're going to use a CityBike data set, which is basically provisioned publicly available through Snowflake. This provides the data around the CityBike usage within the city of New York. This particular data, is basically available publicly and is stored right now on the stage on the S3 bucket in AWS. So we'll quickly go, and what we'll do as part of this is, we'll create a data first. We'll just create a database called CityBike. If you look on the left-hand side, we don't have a database called CityBike, but we do have these 3 databases which comes along with the Snowflake trial account. We're not going to use this. But we'll just create our own database. Once this is created, you can see a message on the bottom. You can refresh it, and you can see the CityBike database. Now we'll also create a table called as trips, and basically, just to show you the syntax, this is like any other table that you create in, when you are using a SQL database. Another important thing to understand from Snowflake perspective, that it supports a wide range of data types. So if you are using something, if you're using, say, a varchar in another database, and when you move to Snowflake, you can still continue to use the same DDL because it supports both string and varchar. Similarly, for the same data type, it supports all those data types. So it's very easy to migrate from or move the structures from your previous databases to Snowflake. Now I just executed this, and within CityBike, I did not create a new schema, so I just use the public schema, and you'll notice that the table is created. Now, when you click on the table on the left-hand side, you can see currently there are no rows, and it will tell you all the columns that the table has, and currently it has no data set. I can click on preview data, and it can tell me the amount of data I have, which is going to be 0 right now. The other thing is or one thing which is different in Snowflake is that Snowflake is a cloud. It's basically based out of cloud, and you have to provision, or you have to make the data available so that it can be loaded within Snowflake. So there is a concept called a stage, wherein a location which the Snowflake can read. There are 2 kinds of stages in Snowflake. One is called as internal stage, and the other is called as external stage. Internal stage is a space within Snowflake that it provides. And you can basically copy your files to the stage location, before it can be loaded into a table within Snowflake. The other option is called as external stage, which is basically a storage location on one of the cloud providers. So it could be like an S3 bucket on AWS. It could be like an Azure Blob Storage, or it could be any similar kind of a structure on the Google Cloud Platform. So for the purpose of this demo, we are using the CityBike trip data, which is in the S3 bucket. This is the URL that we have. Now we don't have this is not a production system, it's publicly available, but while creating the stage, you create the stage with a name, you provide the URL. And if it is a production environment, you will have some key or credential information associated with it. But currently we don't need that. So I can just create a stage pointing to the stage location. And then, I can use an option called as list, which will tell me the list of all the files that are available, that we are going to load. So these are the files which are there. There are around 376 files. The data is around 65 million records or so, and this is around 2 GB of data. Now, before we load the data, we are also going to create a file format, which is basically just telling, what format the file is coming in. For us, this is just a CSV file. Again, this is typical database. When you're creating a database, you can have a named file format. And we're just creating something called as a CSV, wherein we are providing what is going to be the delimiter, whether the header is there or not, and things like that. Now, once the data is staged, now we are going to load the data within Snowflake. So you can use something called as a copy into command. Now, this is again, this is very specific to Snowflake. So you use copy into, and you name the table that is within Snowflake, and this is the stage location from where you're reading the file. And you're going to provide the file format. So we are going to use a CSV file format. So right now I'm using a small, warehouse. So when I run with a small warehouse, it is going to take some time because there are around 376 files. It's around 61 million records, and it will take, I think, around about 30 seconds or so to, to run or load this data set. But the interesting thing, or the thing within Snowflake, is that now you've noticed that it is taking probably more time. If 30 seconds is not acceptable, you have an option to basically change the size of your warehouse, and you can load it much faster. So if you look at this, it has loaded all the files, and it has given you a summary of what has happened with each file. So it tells you the number of rows passed, if there were any errors around it. If there were errors, it will list down those errors. Now you can, of course, load this much faster. I'll just quickly show you the data. I can do a refresh here, and it will tell me the data. You can see there are around 61 million records, 1.6 GB worth of compressed data. And when I do preview data, it will show me the data in a table format. Now, if I want to, basically use a bigger compute, because I don't want to spend 30 seconds loading data. I might have more data. I will change this. I just resized my warehouse to say large, and once the large warehouse is provisioned, I'll truncate my table, okay, and I'm going to load this data again. Okay, same query. I'm going to run this again. And now, earlier I had 2 servers running. Now I have 8 servers running, and the performance is going to be better than how it was. So earlier it was maybe say 30 seconds. Right now, it will come down, and I can say it's around 11 seconds. So it's 1/3 the performance, improvement that you've gained out of it. Of course, you can play around with your warehouse sizes and see which one works for you, and basically choose the right size warehouse that you have. I think the other important point. Sorry, was there a question?
Time check real quick, Drew. We get about 10 minutes.
Yeah. Okay. Thanks, Greg. Okay. So the other thing which Greg had mentioned earlier, that you basically have different teams and you can provision different warehouses. So we use one warehouse called compute warehouse to run the data load process, and maybe your dev team or ETL teams is using that warehouse. But now the analytics team want access to the data to run their queries. You can provision a totally different set of warehouse. They will have their own set of servers running. It will not step onto what ETL or a dev team is doing, and they can scale it up and down independent of each other. So this adds a whole lot of benefit in terms of how do you want to scale your infrastructure for one team against the other, and it's just a click away. So I can click, I can create a new warehouse called Analytics warehouse, and I can just run this query. You can see that the warehouse has changed here. I do have access to both the warehouses right now, but I don't. I'm going to use the Analytics warehouse to run this query, which is on the city bike data, which is basically just finding out for each day what is the total number of trips that were taken, what is the average duration, and things like that. I think other thing which Greg had mentioned earlier was basically talking about the caching mechanism. So you'll notice that right now it took around 3 seconds. You can also see that it gives you a summary of where the time was taken. But the moment you hit this, at the moment this query was hit the first time, it basically got registered with results cache. Now the result cache maintains the data for the last 24 hours. So if you run this query again, it is not going to use your warehouse to query the database again, but rather it will go against your result cache, and it will basically fetch that. So you see, right now, earlier it was around 3 seconds. Now it is 1.6, which I think is still more. If you go again, you'll see that the data set is only 623 milliseconds. So you do get a lot of benefit out of the caching itself. The other advantage is that it is not using the warehouse. When it is not using the warehouse, it is not incurring any compute cost. The other option, which basically we're talking about, was the zero copy cloning. So zero copy cloning is basically a cloning option that Snowflake has, wherein you basically can create the clone of an existing table, a schema, or a database, and by using the command clone. So you can imagine it to be a use case like a production environment, wherein you want to create clones and create something like a dev environment or a QA environment. You can just use a clone object, and it will create that with a click of it. Why is it called zero copy cloning? Is that behind the scene, it is actually just a pointer to the same table, but it is not. So it is not copying the data itself. It is not incurring any additional storage cost. But after this clone is created, any further modifications that are done to, say, trips or the copy, the clone that we created, that will basically incur, it will not impact each other. So trips will have its own modifications, and trips dev will have its own modifications. Okay. I'll probably skip a little bit on the, so far we've looked at the structured data, and the next is basically the unstructured data. But the most of the processes that you follow within the unstructured data is the same. You create a database, and you basically create a table. The only difference that you'll notice in this case is that you are using a data type called as variant. Now, unstructured data in Snowflake can be an XML, a JSON, Avro, Parquet, ORC files. So you can basically, create any file structure by using the variant data type. So we have some data available, which is unstructured data, which is a weather data. It is it is available on the S3 bucket, so we can create a stage for this and load that, and I can show you the file that is there for this one, and you can basically again use the copy into command, very similar to how we loaded the structured data. So it will load the data into into the table called as JSON weather data. It is reading from this particular stage location. The only difference now you see is that the file format is JSON. Now I can query that particular table with a select statement, and that will show me the records that were loaded by that. If I click on this, you can show me individual records. This is the JSON format file that is there. You can, the advantage of using Snowflake is that it comes along with some capabilities to basically traverse within the JSON object itself. So you can use that object, column name, and then you can use the attribute name, and you can use dot notations to traverse through it. So it's basically a select statement, and you basically are accessing the data using the select statement. You can create a view now on top of that, and then you can access the data as a structured data. So what you did was you stored everything as a JSON format, but you created a view out of it, and you're now accessing, those as a structured data. I'll skip this right now because we don't have enough time, but it's very, it should give you an idea that structured data and unstructured data, not unstructured but semi-structured data, will can be accessed fairly in a similar fashion within Snowflake. And I think I'll jump on to the last topic, which is around time travel. So time travel in Snowflake is basically an inherent property wherein each table within Snowflake comes with by default 24 hours of sorry, was there a question?
No, go ahead.
Okay. So yeah, so time travel is basically, within each table within Snowflake, the data is retained, or any changes that happen in the last 24 hours are retained. And if you have an enterprise edition, it can go up till like 90 days. So if you make some modifications today, it will, you can still go back in time and see what was the changes earlier on. Now, this helps, in a lot of conditions, and there are, multiple options which Snowflake has provided, which helps you take advantage of the time travel. One of those options is the drop and undrop. So I think most of us might have, while working on the production system or any other environment, intentionally or unintentionally, might have used a drop table something, and then you've realized that I didn't want to drop that. What do I do now? Ideally, you load the data again, or you go and search for a backup. But in case of Snowflake, you can just use an undrop the table and the table name. And because it supports time travel, it has already a state of the database from the last, before the drop command was run, and it will basically restore your table just with an undrop table command and within seconds. The other option is, suppose you updated, something in the table, and now you want to go back to how the state was before the query was run. So what you can use, you can also do that again with the time travel option, wherein if you have access to the query ID, or if you know what time that query was run, you can use that information to, to do a query on that particular table, and using a before or an at option. And instead of, you can have a statement, or you can have a time at, timestamp, and you can go back in time. And if you want to retain your table to that state, you can of course do a create or replace on top of it. So these are some of the options which are available from Snowflake. I think in the interest of time, I think that basically does cover most of the things that we wanted to basically cover. We talked about the web UI, we talked about data ingestion for both structured and semi-structured. We talked about warehouses, and I think we talked about time travel on a high level.
Thanks, Drew. That was great.
Sure.
So Katie, we got 1 minute left, or 0 minutes left.
So I just want to let everybody know that it is 1 o'clock. So if you have got a meeting you need to jump to, you can go ahead and do that. But, we're not closing down the doors and, shutting up the windows. I think Greg and Tarun have a little bit more time. So are there any questions that we can ask? If you have a noisy environment, you just want to type your question, or you'd like me to ask your question for you, go ahead and throw that in chat, and I can ask that as well. But I did want to let people know that it is 1 o'clock, so if you do need to go, you can do that. Andrew, do you have a question?
Hello. Yeah, sure. I know obviously you won't know the exact. I've looked a little bit for the pricing kind of on that. If you have any kind of details on, like, obviously not the exact cost, but just kind of how it's based. I'm guessing since a lot of this, like, it's going to be kind of a combination of Snowflake plus, whatever cloud platform you're using is where a lot of the.
Actually, it's Snowflake passes on the, so you have basically two aspects, as Tarun mentioned. So you have your storage and you have your compute. Your storage, Snowflake is effectively passing on the cost directly to you. So whatever, and the price they quote for that is $23 per compressed terabyte per month, which is, really cheap. And then for your compute, they basically have a concept of credits. And depending on the compute warehouse that you use, and also I think your level, you consume those credits, and then there's an assigned dollar figure to the credits. And so that's how your costing is done.
Okay, thanks, that helps.
Great question. Anybody else?
So I know you guys said that Snowflake works on all 3 major cloud platforms. We've had experience with other tools that work on all 3 cloud platforms, but some are a subset of features than others, and some it runs more performant on than others. Is there a cloud platform it is more performant on, or do all have high performance in all features?
I have not heard anything that there's a performance difference in any of the cloud platforms. What I will say is they started on AWS a few years ago. They then added support for Azure, and then GCP was last. And I know that GCP a while ago maybe had a little bit limited feature set and functionality set. I honestly don't know whether they've gotten it fully up to speed yet, but I'll just offer that unless Tarun has some other thoughts there.
Yeah, no, exactly the point. I mean, what you mentioned, Greg. The support for GCP has, has been incremental, and I think they rolled out a majority of that this year. But it's still catching up there. But for AWS and Azure, it's pretty much neck to neck. Yeah.
Andrew, you have another question?
Sure. Does this does it kind of do away with the concept of indexes and stuff that you have on traditional databases?
Yeah.
Indexes.
Yeah. So the entire performance aspect of it is then on Snowflake now. There is no concept of indexing, and there is something called as cluster keys that you can define, but then it has very specific use cases. And if the data increases beyond, say, 1 terabyte of data for individual tables, only then it recommends to follow that. But even in that case, it says that Snowflake will handle it.
Yeah. So a cluster key is somewhat equivalent to the Oracle partitioning concept. Think along those lines. But yeah, it doesn't use indexing handles. It again, that's part of what Snowflake does. Is it takes away all that management and query performance tuning and deals with it for you.
Huh, that's amazing.
It is. I was a skeptic, but I'm sold.
And is there any kind of like ramp up, like, hey, you load that huge table and, maybe takes it?
Yeah, I mean, don't get me wrong. There aren't, it's not magic. So there are still some work that you may have to do to manage very large. And, we were just on a call the other day with a customer talking about possibly partitioning the data, creating materialized views or other views. So there is a little bit, but the vast majority of that effort is removed.
Yeah. Great. That's really cool.
Any other questions, comments?
You said it cached the results, and then once it has that query plan executed and cached results, it never goes back and reruns it, or something like that. How long do those stay cached? How much tuning do you have to do if you've got an app that's doing constantly different types of queries that it will get rid of those or maintain those? Like, how much tuning are you doing, or does it do that automatically, saying, okay, I haven't seen this one ran in 36 hours, I'm going to throw it away, or does it always keep it until the data changes?
You don't manage it, but the cache, Tarun, you want to handle? I know you have the actual statistics.
Yeah. So basically, cache, it's 3-layer cache, and it manages on its own, but it is very transparent in that manner. So there is a results cache, which basically maintains the data for the last 24 hours, unless there is, the underlying data has changed. So if nothing has changed within that, the data, and if the query doesn't get access again, it will basically retain it for 24 hours. The other level of caching is at the warehouse level. So if you have the warehouse always running, which incurs costs, but if you have the warehouse always running, the cache is maintained there as well. So you have to then, balance it out and see cost versus performance and, take that call. But it's pretty performant if you have the cache enabled, even at the warehouse level. Does that answer your question?
Yeah, I was just wanting to know if you had to maintain that. So 24 hours, is that configurable at all, or always just 24 hours?
It's always 24 hours. There's no configurations around it. You can bypass that though. I mean, there are certain session variables that you can use wherein if you don't want to use the cache, you can set that and let it bypass the results cache.
you guys typically like do a Monday morning warm up? Like if you've got a high performance application that kicks off Monday morning, do you ever just kind of pre-run some queries that are common and warm it up so the user experience is better, or is it not really a problem in your experience?
Yeah, I think more than the caching, it has not been a problem. You can always play around with the size of the warehouse, which can help you improve most of those performance, if at all you encounter those. So I think Snowflake is quite good, performant that ways. We've not encountered that issue, but results cache and warehouse cache are ways to improve upon that. We've not encountered that, but what you suggested, can be a possible solution if you do hit a bottleneck somewhere.
Perfect, thank you.
Any other questions? Going once. Going twice.
Sorry.
Go ahead, Andy.
Yeah, I know you guys did a good job of showing kind of how you get some data in there. Can you talk a little bit about what you do if you're pulling from another relational database, from Azure or whatever else, Postgres, or do you kind of have to do some of that side to get in, or how would you go about that?
So most of the data, has to be staged. As we talked about, either when you have a data or you have a database offline, on premise, or on cloud, you will have to stage it to a location. It can be an internal stage, which we talked about, or it can be has to be one of the cloud providers. So it can be an S3 bucket or an Azure blob storage. And from there on, then that is where you make it available for Snowflake, and then Snowflake can basically read from that. What Snowflake provides in this mechanism is a CLI tool. So if you don't have one of the cloud providers, or you can use a CLI tool. You can extract the data from those. You can have you can still use your ETL jobs, and create an extract and place them at the stage from where the Snowflake can then read it.
So yeah, basically there is no direct ingestion from an external table or database.
Okay, just as a time check, we're 10 after, so if you got to make a run for it, go ahead. But do we have any more questions? Going once. Going twice. Sold. Oh, go ahead. Nope, I was going to wrap up, but you're good. Go ahead and ask your question. Ask away. That's what we're here for, is questions. Bring it on. Well, if not, we'll go ahead and get the recording wrapped up and whatnot here. In the chat, I'm throwing my contact information. So you can email me at katiendo@smartdata.net. It's in the chat, so if you need spelling. Or you can hit us up on social media at Smart Data or Costrategix. But we will be putting out the recording for this, so if you've got a coworker that you're like, oh, they would love this, we're going to be putting that out as well, so watch for that. I think I might also be getting slides. We'll check on that, but we'll have it all available on the Smart Data website, and we'll be sharing that on our social medias as well. So, and if you're interested and want to know more, Costrategix would love to have a chat with you if you want to have a demo for your own team. I'm sure they would love to help you out and answer all the questions that you have. So, Greg, Tarun, thank you so much for presenting, and thank you to everybody who was able to join today. If you would like to present, or you know somebody who has some great knowledge and you think they'd be a great presenter, go ahead and let me know. You can either talk to me afterwards or hit me up at that email address, and watch for our next one on September 17th on fantasy football.
Okay. Thanks, Katie.
Yeah,
Thanks,
everybody, have a great day.
Thank you. Thank you.
Thank you.